Part 3 of Lesson 5, Chapter 2 is on solving rational equations. Again, when you see the word rational, that means that you have fractions. You can see in this equation that we need to solve, we've got fractions. Typically, you'll have variables in the bottom of the fraction. The first step in solving rational equations is to use an LCD. LCD stands for least common denominator. What you want to do is you want to multiply everything times the LCD. On this problem, the LCD is y. So we're going to take y times this term, and that's going to give us y squared. Then we take the LCD times this term, and that's going to give us just 6, because it's going to give us 6y over y. Then we take the LCD times this term, and we'll get equals 5y. And so now it's a quadratic equation, much easier to solve. Get everything to one side by moving the 5y over, factor it, and we end up getting two values, 2 and 3. Now, one of the things you have to do with rational equations is you have to check to see if these answers are extraneous. An extraneous solution is one that works out algebraically using all the rules of algebra, but doesn't confirm numerically. So, how do we check if they're extraneous? We put them back in. If I take the 2 and put it back in, we'd get this equation, 2 plus 6 over 2. And does that equal the right-hand side 5? Yeah, 2 plus 3 equals 5. If I test the other value of 3, we'd have 3 plus 6 over 3. And does that equal 5? Yes, it does. So, both of these solutions are real solutions. Neither of them are extraneous. Next problem, same directions. We have to solve the rational equation. It's got fractions in it. We want to begin by multiplying everything by the LCD. Now in this problem, the LCD is going to be not just a letter like the last problem. It's going to be an expression, x minus 8. And we're going to have to take this LCD and times it by each term. So we begin and we'll get x times x minus 8. Now when we multiply those, the x minus 8's cancel, so we just get 6. And then anything times 0, of course, is just 0. So this equation is much easier to solve. It's a quadratic equation. We get x squared minus 8x plus 6. And now what's different about this problem versus the last one is we have a quadratic that's not factorable. So then we have to use the quadratic formula. So in solving with the quadratic formula, we end up getting 8 over 2, which is 4, plus or minus. This is going to give us 64 minus 24, which is the square root of 40, still being divided by 2. Now the square root of 40 can be broken down into square root of 4 times square root of 10. Again, that's still over 2, and thus you can cancel the square root of 4 and the 2, and you just get 4 plus or minus square root of 10. Now we still have to check to see if these are extraneous, and we're going to use the calculator to help us with that. So let me show you how we do that. First thing we do is we type in 4 plus the square root of 10 and get a decimal approximation. And then I'm going to put it back into this equation, and so I'm going to use the answer function. Second negative sign, ANS, stands for use the previous answer. So anytime you see ANS, it's going to use the 7.16227766, so on and so forth. And the rest of the equation looks like we have to add the fraction 6 divided by x minus 8. So we go answer minus 8. And now when we press enter, we're hoping to get the right-hand side, which is equal to 0. Okay, that confirms that 4 plus square root of 10 is a real solution. So now we got to test the other value, 4 minus square root of 10. And that gives us a different decimal approximation. And so now to put that back into the equation, we get answer plus fraction 6 divided by ans minus 8. And again, I'm hoping to get 0 when I press enter. And this confirms that both 4 plus the square root of 10 and 4 minus the square root of 10 are both real solutions, no extraneous ones. The last example I have for you today is solving again a rational equation. This one's going to end up with extraneous solution or solutions. So what's a little bit different on this one is you see 3 different looking denominators. Usually when you have that, one of your denominators will factor into the other 2. So let's try to factor this guy. Sure enough, we get x minus 4 and x minus 2 for the factors of that first denominator. Now we're going to have to take this whole equation and multiply by the LCD, which is x minus 4, x minus 2. Okay? So we distribute the LCD to each term. Now when I take it to the term on the left, everything cancels out, and I end up just with a 4. When I take the LCD times this term, the x minus 2's cancel, so we get 3x times x minus 4. And then when I take the LCD times this last term, the x minus 4's cancel out, and so we're left with 2 times x minus 2. Doing some distributing, we get 3x squared minus 12x plus 2x minus 4. Get everything to one side. We got 3x squared minus 10x and then minus 8. Now to continue solving that, I'm going to take the 3 and send it to the back, giving us a quadratic that's easier to factor. X squared minus 10x minus 24. This factors into x minus 12, x plus 2. Now you got to make up for sending the 3 to the back by dividing these both by 3. So we get x minus 4, and then this goes to 3x plus 2. So our 2 solutions would be positive 4 and negative 2/3. But I'm guessing one of these is extraneous. Now if you try putting these back in, it's going to be pretty obvious that this is the extraneous solution. Because if you put 4 back in, notice right here you're going to end up with a 0 on the bottom of a fraction. And you can't have that. That's what's going to make it extraneous. The negative 2/3 you could put in, and thus that is going to be a real solution. Okay? Basically the only 2 values that would be labeled as extraneous for this problem would be positive 2 and positive 4. We didn't get a positive 2 for an answer, but we did get positive 4 for an answer. How about back on this problem? What would be the only answer that we would label as extraneous if we had gotten it? It'd be the value of 8, because that would make a 0 on the bottom. How about on our first problem? What would be the only value that would be labeled as extraneous if we had gotten it? It would be 0, because that would produce a 0 on the bottom of the fraction. So hopefully you're understanding those extraneous solutions. Here's the problems that you're going to be working on in class.